Hi, so for my robotics laboratory, this is laboratory activity number 2 entitled Control of Stepper Motor. So for the objectives, this experiment will enable the student to control the direction of rotation of a stepper motor using H-bridge circuit, to control the speed of rotation of a stepper motor, to control the angular displacement of the stepper, and to create a computer program user interfaces and data control to Arduino. This last objective here will be disregarded since we were not asked by our professor to do a program user interface. So the equipments and materials that we're going to need for this experiment are the following: a personal computer, one Arduino microcontroller, one L293D motor driver, one power supply. For the power supply, I would be using this cord. This end of the cord here is to be connected to the power port of the Arduino Uno, and this one is for the personal computer USB port. One breadboard, alligator clips, one set of connecting wires. So for a brief introduction, Arduino conveyor and a stepper motor were used for this experiment. The movement of the conveyor is controlled by the stepper motor through a program implemented in Visual Studio and Arduino. Visual Studio is a computer software that used to develop a program with an interface. So again, we're not going to use the Visual Studio but just used Arduino microcontroller and its application Arduino serial monitor. Arduino is an open source platform used for building electronic projects. The communication between the Arduino and Visual Studio is done using ASC2 over serial USB. Again, we're not going to use that too, and the Arduino will control the stepper motor and the Visual Studio will provide the interface to execute the command. So here, the Arduino will still control the stepper motor and the Arduino application serial monitor will provide for the interface. I will execute for the interface. So this interface is for just when we're going to use the Visual Studio, so we're not going to use that, so let's just skip that. So these are the procedures. We're asked to connect the computer and Arduino microcontroller using USB serial cable. So there, and this is the schematic diagram and the connection of the pins here. So this will be our guide. So heading on to the Arduino program, the first problem is that we're asked to create a program that will control the direction of the motor by sending the right sequence of pulse to the motor, sending the sequence of pulse to make the motor rotate clockwise, sending the sequence of pulse in reverse in order to make the motor rotate counterclockwise, and stop sending pulse will cause the motor to stop. These are the experiment results. This is how I connected the circuit using a USB serial cable, and the circuit connection here, I used this pin out for the L293D for guide, and this is the schematic diagram that I used for guide also, and this is the circuit assembly that I also used for my guide. I used FitZenk application for this. So for the code, let's check for the interface code. For the code, we're asked to create a code for the program that it will rotate clockwise when character A is typed on the serial monitor, and the motor will rotate counterclockwise if character B is inserted or typed in the serial monitor, and the motor will stop if character C is to be typed in the serial monitor. So here's the code. So let's head on to the Arduino application to see if this code works. So now let's head on to our Arduino application. So as you can see here, this is the code. So here I've included the stepper library This is the character dir, this integer and constant integer for the step, so SPR is equal to 20. The stepper pins that are used for in the Arduino microcontroller are 8, 9, 10, and 11. These are from the stepper library. So next, for the void setup, so the serial baud is 9600 and the stepper speed is at 100. So here is just some header for the serial monitor, for the instruction and the name of the laboratory. And for the code itself, so void loop dir, when the serial monitor reads a value, let's say for example A, it would rotate clockwise, and B counterclockwise, and when it reads C, it would stop. So let's now check on the program if it's working. Let's click on upload. See, compiling sketch, uploading, done uploading. And next to do is go on tools, serial monitor, and as you can see here are the instructions. So now let's check if I'm to type on A, it should rotate clockwise. So as you can see, the motor rotates clockwise in a very slow 100 speed. And if I'm to type B, it should rotate counterclockwise. So there, as seen from the motor. And C, it should stop there. The second problem in this experiment that we're asked to do is create a program that will control the speed of the motor by controlling the pulse frequency of the microcontroller. So the same connection from the previous problem number 1, and also I used this L293D. These are just the same connections as the previous experiment. The previous problem rather. So for the code, this is where it's different. We're asked to create a code for the program that will send integer value that corresponds to the rotational speed of the motor. So this is the code. So let's head on to the Arduino application and check if this code works. So let's head on to the Arduino application. So here's the code. So here again, I included the stepper library, and the integer speed and constant integer SPR value is 20. The stepper is for the pins in the microcontroller Arduino. So from the library, it should be using 8, 9, 10, and 11 pins. So next, for the setup, void setup, serial.begin baud value is 9600, and the void loop, this is the main code. So when a number or a value is inputted in the serial monitor, it should read as its speed, and if the speed is greater than 0, then the set speed should make the serial monitor turn clockwise. So the serial print ln, this serial.println will just display the speed in our serial monitor, and my stepper.step is value is 2000. So let's upload the program in our microcontroller. So done uploading. So now what we need to do is open our serial monitor. And as you can see here, to control the speed of the motor, type a value, and note the motor will rotate one complete cycle before reading the next value inputted. So first, let's try a value of 500. Enter. There, as you can see, turns one turn, and it still turns 500 after one complete cycle. So now if I'm to increase the speed to 1000, see, as you can see, when it finished its one cycle, it changed the speed. Now let's try 1500. There, as you can see, it turned faster. Now let's try a slower speed, 300. There. And lastly, for our experiment 2, we're asked to create a program that will control the angular displacement of the motor by sending a number of steps in the microcontroller. I also used the same connection, the same IC, the same schematic diagram, and the same circuit assembly. The difference only is with the code. So since here for the interface, we're asked to create a code for the program that it will send integer value that corresponds to the number of steps the motor will take. So this is the code for the stepper angular displacement. So let's head on to the Arduino application and check if our code works. So here at the Arduino application, this is the code. So again, I included the stepper library. The integer is steps, constant integer value is SPR equals 20, and the pins in the microcontroller are 8, 9, 10, 11 according to the stepper library. So here, the point setup, the serial will begin at 9600 baud and the speed is at 1000. So this is just the header for the serial monitor, and this is the main code. So void loop, when value is inserted in the serial monitor, it would be equal to steps, and if the value steps is greater than 0, then my stepper.step, it would the value inputted would be the value of the step in the stepper. So, and it would print serial.println the value of the step inputted in the serial monitor. So let's check. So first let's upload. So uploading, done uploading. Now let's check serial monitor. So there, to control the angular displacement of the stepper motor, type the value. So as we type the value here, as we type a value here, that would be the angle that the stepper would turn. So let's input the value of 20. That's 20 for the stepper. Now let's try a larger number, 50. Oh no, let's try 100. And we should observe a greater turn there. And let's try 500 there. Now let's try 1000. Now again, let's try 400, 200, 100, 1500. So as you could observe, the greater the value, the greater the turn the stepper motor makes, the greater its angle, and the lower the value, the less angle it turns. So let's try 300 again, and 1000. There.